Al- When you rub a plastic scale on your hair, you can charge it. Metal scale, it won't charge. So you can only you can only build up electrostatic charge on a plastic scale by friction. The primary way is friction. Just rub it, electrons get transferred. But metals, you cannot rub by charge by friction. You need conduction or induction. Conduction is when you touch something. Induction is when you do it without bring a charged body near it, and then you do this that procedure I explained. Now, there's a here metals have a sea of electrons, but the positive charges are fixed. Here, uh, here also the positive charges are fixed, but the C, there's no C, absence of C. The charges are sticking only to the valence, to the bonds, to the bonds, like at some localized positions. So you can, if you even if you hold this in your hand, nothing will happen. The charge won't lose, and you can easily charge it. But if this you hold, charges will go straight through your body. And here, what happens is the charge stays localized, it stays fixed at a point. Here, it will just spread because the free electrons can just move around, and this will hold charge for some time. This will lose charge instantaneously. Of course, it has to be dry air. Uh, so the similarities are is basically the movement of free electrons. But here and the conservation of in metals, the free electrons are very free, and electrons only come within the valence bonds. There are bonds present between two atoms. The electrons are concentrated there. Conservation of charge is held means that if it loses same number of protons, it will get positive charge, or same number of electrons, it will get positive charge, equal to that. And there is attraction, and there is polarization if you have a neutral the thing. These are the similarities. These are the differences. So always remember, if you get a question, if you have to be very clear. This question was plastic rod. So this was localized. If you rub it, it will stay here. Because if you got like plastic is just a polymer. So it's just a polymer. The electrons will get come out from here, but they will remain localized. They can't just move around. Here, there's a lattice. There's copper at positions. At the free electrons, they are moving around. So the this protons, they won't, the positive charge will never move. So some protons move to the left. Whenever there's a positive charge, no, it doesn't move, it doesn't move, it doesn't move, cannot move. The negative charge moves to the right. So the negative charge will move to the left. Of course, there will be some negative here also, but less. The positive charge will be always there where it was, but this part will become excess of free electrons, and this part will become deficient. So we will have a negative charge here, even though the positive ions are still there. Positive ions are still there, but there's an excess of electrons here because of the attraction they are having. Understood? Also, that whenever they talk of force, there's a formula which gives you some idea to explain. You don't have to write it in your exam. The formula is a constant multiplied by charges over the distance between them. The distance here is this distance r. So the more the distance, less the force. More the distance, less the force. The product of this, the two charges like Q1 and Q2, that will give you the force. If both of them are positive, they will repel. If both of them are negative, they will repel. If both of them are, one is positive, one is negative, then they will attract. So whenever the product is positive, it will repel. Whenever the product is negative, it will attract. So this formula you can keep in mind. It helps to explain. Now, uh, this helps to explain why if you bring a scale near a paper, why does it, even though this is neutral, Why does it get attracted? You see, if you got a positive scale or whatever, the electrons will come here and the protons. So you will say, okay, let's say I have got some charge being created. There will be minus 3 coulomb charges in coulomb and plus 3 coulomb here. It total may it's still neutral. In totality, it is still neutral. But there is a pole happened, a negative pole this side and a positive pole this side. Now, what will happen is this will start getting attracted to the negative. Now, you might say, if this is getting attracted and this is getting repelled, why do we have the same charge? Okay. Like if there is a charge here q1 and there is minus 3 here plus 3c, I multiply q1 by minus 3c in one case and I multiply q1 by plus 3c in the other case. So why does this, if the repulsion and the attraction is present, why does it get attracted? Because the distance here will be less. Because the negative and the positive are closer. So this distance is less. So the force is more. So the attractive force is more compared to the repelling force. Did you understand?